Hello everyone, today we're going to take a look at tolerance and fates, which are when the holes and the shafts they go together, what's the tolerance in between, and how do they fit together. And before we start this chapter, let's take a look at the table that we're going to use for this chapter first. So I'm going to be out of here and bring the table in. So here are the table sites that we're going to use. So on the table there are 5 types of fates. So the first 2 they are clearance fate. The third one is the transition fate, and the last 2 they're interference fate. Clearance fate means you have a big hole and a little shaft. And interference fate means you have big shaft, little hole. And transition fate means the holes or shaft, either one could be bigger than the other. So like we said, the first 2, they are clearance fate. The first one is called running and the sliding fate. And there are 2 pages for this. And the third one and the second one is called the clearance locational fate, and the next one is transition fate, so transition locational fate, and the next one is interference locational fate, and the last one is force and shrink fates. So the tolerance is going to be tolerance is pretty big in between the first one, and you have a big hole, little shaft. And the second one, tolerance is getting tighter in between, but you still have big hole, little shaft. And the third one, so either hole or shaft, either one could be bigger than the other. And the next one, interference fate, so you're going to have a big shaft, little hole. And the last one, force and shrink fate, you are going to have big shaft, little hole as well, but the shaft is going to be kind of a bigger than the hole size instead of just the interference locational fate. So those are the difference. And first of all, I'm going to go to the first page, so pay attention here. Limits, they're all in thousandths of an inch, which means if you read the number here, the number is not 0.2 but 0.0002, 3 zeros after the decimal place, because they're all thousandths of an inch. So if you read at the nominal size, so this is the nominal size. So when your holes, when the nominal diameter, either the holes or the shaft, in this case, they're all holes because they're all using standard hole system, because they're all starting from 0, the hole size. So they're all using standard hole system. So the nominal size is going to be the hole size. So when the hole size is between 0 to 0.12, then you're going to use the tolerance here. And when the hole size, nominal size, is between 0.12 to 0.24, and those are the tolerance that you're going to read. So apparently the hole size is smaller than 0.12, then your tolerance will not going to be 0.2. This is even bigger than the hole size. So all those numbers, they are in thousandths of an inch. So in other words, so this number is 0 thousandths of an inch and 2/10. And same thing of this number is going to be 0 thousandths of an inch and 3/10, which is 0.0003. This is the tolerance. And the same thing for the limits. So limit is the space between the hole and the shafts. That's the limits in between. And also it says over 2. So if I have a hole's diameter that is exactly 0.12, then I'm going to take this row here because it says 2 and over. So this means any diameter is greater than 0.12, then I'm going to use this row. So if my dimension is exactly 0.12, I'm going to use the first row. And also for each fate, they have, so if you see class RC, it means it's running and the sliding fates. And you have a class 1, class 2, class 3, class 4. And the next page, 5, 6, 7, 8, 9, and those are the nominal hole's diameter. So this is the running and the sliding fates. And the next page is clearance locational fates. So same thing. The first column is the nominal size. So nominal size of the hole. And if you see the class is LC, it means they are talking about clearance locational fates. You have class 1, 2, 3, 4, 5, 6, 7, 8 until 11. And once again, all those numbers, they're thousandths of an inch. So this number is actually 0.00025 inch. So 3 zeros before the 25 because it's a thousandth of an inch. And the next one is transitional locational fates. So if you see LT, it means transition locational fates. And once again, the first column is the nominal size, and here are the tolerance. And the next one is interference fates, which you're going to have a big shaft and a little hole. And this is the nominal size, and all the corresponding tolerance are in the middle, and they're all in 1,000th of an inch. And the last one is a force and shrink fates. So you have a nominal diameter and all the tolerance here as well. So you have a hole tolerance and the shaft tolerance and also the limits here. So if I'm asking the hole tolerance, so first of all you find the nominal dimension. Let's say if it's in this range, and your hole tolerance is going to be, the lower limit is going to be 0 and the upper limit is going to be 0.3 for hole. And for the shaft, the lower limit is going to be plus 0.4 and the upper limit is going to be plus 0.6 if it's in class FN1 fate. And we could practice one more. So let's say if I gave you the class RC3 fate and the diameter of the hole is 0.3, then 0.3 is in this range, so you're going to search for this, and the hole tolerance is going to be from 0 until plus 0.6, and the tolerance for the shaft is going to be from minus 0.9 until minus 0.5. So this is how to look up the table. Okay, so let's go back to our homework problem. And this is the homework. So first of all, let's talk about the first example. It says if the nominal size of the hole is diameter is 0.75 inch, and it's in FN1 class of fate, and determine the type of fate and the hole limits, the maximum and minimum size of the hole, and the limits of either clearance or fate or interference, depending on what type of fate this is, and also the shaft limits. So first of all, let's remember this number, the nominal size, 3/4, and it's Fn. So let's look up the table and figure out the type of a fate first. So I'm going to get out of here and bring the slide here and make it bigger. So it was Fn. So let's go here. So Fn is here, so it's going to be in a force and the shrink fates. And it's asking class 1, class Fn1, and the diameter is 3/4 of an inch, so 3.75. We're in this category. Okay, we're in this category. So we have the hose diameter and the shaft diameter. And let me bring the slides in here as well so we can compare. So move this one here, this one here. So we have so it's going to be force and the shrink fate first, because it's a force and the shrink fate. And for the hose diameter, so 3/4, we're here, so this is the hose diameter, and I put it here. Once again, it's a 1,000 of an inch, so you need the 3 zeros in front. And the shaft diameter is this number, so 3 decimal places, 3 zeros in between as well, so 7 to 11. So 7 to 11. This is the shaft tolerance. And let's go back to the slides one more time. Then the maximum size of the hole is going to be the nominal size of the hole, which is 3/4 of an inch, and plus the upper tolerance. So upper tolerance, this is the maximum size of the hole. And the minimum size of the hole is going to be the nominal size, actually plus the lower tolerance, since this is a minus, so you can treat it as a plus as well. And this is 0.75 inch. And the limits of interference, we would have to go back to the table here. So it's 75, so this is a limit in between. So from 11, 1.1 until 2. So if I bring it here, so it's from 2 until 11. So this is the limits of interference. And this was the example. And the next one is going to be the homework. So it's going to be the same problem. And the first one is going to be the nominal hose diameter is 1.25 RC5. And the second one is diameter is 1.75 LN2. And RC4 with this diameter, and FN3 with this diameter. So you're going to use the table, so this tables, and find out where each class is, and find the nominal dimension, and find out the tolerance. And you're going to put your answers here, the first one, second one, third one, and the fourth one. And let's take a look at the second example. So the second example is when the hole and the shaft, they meet together. So this is the hole, this is the shaft. So once again, if you have a bigger hole, little shaft, it's clearance fate. So that's example 2. So as you can see, the maximum size of the minimum size of the hole is still bigger than the maximum size of the shaft. So this is a clearance fade. And if you go to example 3, so this is an interference fade, which you have a bigger shaft and a little hole. So if you look at the dimension, the smaller size of the shaft is still bigger than the biggest size of the hole. So shaft is always bigger than the hole. So this is an interference fade. So let's go back to the second example to take a look at this. So first of all, I have the hole dimension and the shaft dimension. First is asking the hole tolerance. So the hole tolerance is going to be the largest hole minus the smallest hole. And if you plug numbers in, the answer is going to be 2,000th and 0.1 of an inch. And the second one is asking the tolerance of the shaft. So the tolerance of the shaft is going to be the maximum size of the shaft minus the minimum size of the shaft. The maximum size of the shaft is this number, and the minimum size is this number. You subtract one from the other. The answer is 0.0012 inch. And the next one is asking the tightest and the lowest fit. So if when you have a tightest fit, then you're going to have the smallest hole in the maximum shaft. So tightest fit means the distance in between is the smallest. So you're inserting the shaft into the hole. So the tightest one is going to be you have the smallest hole and the biggest shaft. So smallest hole dimension is 1, and the largest shaft is 0.9975. So you use 1, subtract 0.9975. This is the tightest fit. And the loosest fit is going to be the biggest space in between. So when you have a largest hole and the smallest shaft. So once again, go back to the picture. When you're inserting the shaft into the hole, then the largest space in between is going to be you have the biggest hole and the smallest shaft. So you plug in the number 1.0020 minus 0.9963. The answer is 0.0057 inch. And the type of fade is going to be a clearance one because you have a big hole and a little shaft. So it's a clearance fade because holes are always bigger than the shafts. And you're going to complete this homework problem on your own, very similar with the one we just talked about, and put your answers here. And the third example, so it's going to be an interference fit because the shaft size is always bigger than the hole size. So first is calculating the tolerance of the hole, which is going to be the maximum size of the hole subtract the minimum size of the hole. So this is the tolerance of the hole. And the tolerance of the shaft is going to be the maximum size of the shaft minus the minimum size of the shaft. So you subtract them. This is the answer. And the next problem is asking for the tightest fit and the loosest fit. So once again, if you want to have the tightest fit, then you're going to have the largest shaft and the smallest hole. You're inserting the shaft into the hole. So when you have the largest shaft and the smallest hole, then it's going to be the tightest fit. And you always want to use holes to subtract the shaft, because this is an interference fit. Then you are expecting a negative number here, because it's interference fit. The fit in between is going to be a negative number. And for the loosest fit is going to be, you have the biggest hole and the smallest shaft. And the biggest hole is this number, and the smallest shaft is going to be this number. And if you subtract them together, you're expecting a negative number as well, because it's an interference fit. So the type of a fit is going to be interference fit, because the shaft size is always bigger than the hole size. So this is the reason. And the homework 3 is very similar with the one we just talked about, example 3. And you can complete all these procedures on your own. And that's all we have for this homework. Thanks for watching the video. We'll see you next time. Bye.